This question comes from Kaum. Let's say a very curious person who asks, what if you jumped into a black hole carrying a mirror? At first glance, it sounds like a physics experiment dreamed up by a sleep-deprived student at 3 in the morning. But let's follow it through because black holes are already weird, and throwing in a mirror only makes them stranger. So you've got your mirror tucked under your arm and you're drifting toward the event horizon, the point of no return. From far away to outside observers, you never actually cross this boundary. Instead, you appear to move slower and slower, red-shifted until you practically freeze in time. To your friends, you just fade into darkness, clutching a mirror like a very confused interstellar barber. But from your perspective, you cross the horizon normally, and now things get complicated. The gravitational field near a black hole isn't just strong, it's extreme. Space and time themselves are being warped like Play-Doh under a steamroller. Normally, when you look in a mirror, light leaves your face, bounces off the mirror, and comes back to your eyes. Simple. But here, light rays are bent, stretched, and sometimes trapped by the intense curvature of space-time. That means your reflection in the mirror won't look the way you expect. As you approach the event horizon, your reflection would start to look distorted. First, you'd see yourself elongated, like someone squashed your face into a cosmic funhouse mirror. The edges of your image might smear, flicker, and even seem to wrap around the mirror itself. You might literally see the back of your head in the mirror, something your barber back on Earth could only dream of showing you. And then comes the really trippy part. Once you're inside the horizon, every possible path light can take bends inward. The photons that usually travel from your face to the mirror and back to your eyes don't get to behave normally anymore. Instead, many of them curve, spiral, or get sucked straight into the singularity. Your mirror could stop reflecting your face entirely, not because it isn't shiny, but because the light never makes the return trip. In a way, the mirror goes blind, but let's get even weirder. Imagine you're falling into a rotating or Kerr black hole. In that case, space-time itself isn't just warped, it's being dragged around like a cosmic whirlpool. Inside this space-time blender, your mirror might reflect not just your face, but scrambled fragments of the entire universe. You could glance into the glass and catch a glimpse of stars, galaxies, and even the distorted image of the event horizon itself, all smeared across your reflection like a surrealist painting. You'd be looking into the universe's strangest selfie. Now, suppose you get really bold and angle the mirror just right. Could you, in theory, use the mirror to look back at yourself from the past? In principle, relativity allows light to take extremely twisted paths near a black hole. It's possible that photons leaving your face a few milliseconds earlier could circle around and hit the mirror, bouncing back into your eyes. If that happened, you wouldn't just see yourself, you'd see a younger version of yourself. Congratulations, you've turned your mirror into a time machine for your own face. Just don't expect it to be flattering. Falling into a black hole is not kind to your skin tone. Of course, physics has a cruel sense of humor. Before you get too excited about time travel selfies, we need to talk about spaghettification. That's the cheerful name physicists give to what happens when tidal forces stretch you out like a noodle. The closer parts of your body feel a much stronger gravitational pull than the farther parts. If you're falling feet first, your legs are tugged harder than your head. Soon, you're longer than an Olympic swimming pool and thinner than a breadstick. At that point, holding onto a mirror isn't just difficult, it's impossible. Unless, of course, the mirror also stretches with you, in which case your last view of existence is your reflection smeared into infinity. But let's be optimistic and say you somehow survive spaghettification, maybe because you're falling into a supermassive black hole where tidal forces near the horizon are actually mild. In that case, you'd have a little more time to play with your mirror. You might even notice something strange. The mirror doesn't just show your reflection, it shows the end of time. Once you cross the event horizon, all paths forward lead to the singularity. Light can't escape. Neither can you. The mirror becomes a kind of cosmic prophecy, reflecting not your present face, but your inevitable doom. That's less of a science experiment and more of a horror movie. Still, there's a poetic side to it. Humans have always used mirrors to ask questions. Who am I? What do I look like? What's stuck in my teeth? But in a black hole, the mirror stops answering those questions. Instead, it becomes a reminder that even the most familiar objects, glass, reflection, light, lose their meaning in the face of extreme physics. So what happens if you jump into a black hole with a mirror? At first, you get a weird cosmic funhouse reflection. Then the mirror might show you warped fragments of the universe, or even a younger version of yourself. Eventually, though, the laws of physics stop playing along. Your reflection disappears, your body stretches, and both you and your trusty mirror are doomed to meet the singularity. It's not a great way to spend an afternoon, but if you ever try it, I have one piece of advice. Don't bother checking your hair in the mirror. Black holes don't care how you look.